way they were meant to be. We're going to be just talking about what is and what is not a function. And a lot of times this seems like it should be an easy thing. In a lot of ways it is, but it's also one of those things that is just is a lot of times more difficult than you want it to be. And so make sure that you understand exactly what each of the definitions mean. And so the two learning targets we wind up being tested on. Number 6, determine whether or not a relation is or is not a function. And then number 7, just be able to use function notation. So we'll be spending a whole lot more time here on number 6 than number 7. But number 6 is definitely one of those where, man, you just think it should be easy, but a lot of times it isn't as easy as you want it to be. All right, so in an effort to make sure that you have all this down, let's make sure that you understand exactly what each of these words mean. Number 1, what is a relation? Well, essentially it comes down to being an ordered pair. And you should probably know what an ordered pair is. An ordered pair is basically just this, an x and a y. Okay, and so this is an ordered pair. This is kind of the underlying thing for a function. So again, you're going to be determining whether or not a relation constitutes a function. So ultimately, here's what a function is. A function is a relation where each x value has only one y value. Okay. Now it seems like that should be pretty basic, and again, many times it is, but so we're going to actually connect this to the vertical line test here in a minute, and that's going to be our real test as to whether or not a relation is a function. Some other things that you're going to need to know really well is domain and range. So domain has a lot of different names for it. Traditionally, we think of it just as your x values. Okay. So your domain is all of your possible x values. Other words for this include independent values. Okay? So your independent values are also your x values, are also your domain. Okay? Another word, not quite used so often, but sometimes we're talking about like algebra theory, you'll hear the phrase input. So input also means independent values, x values, domain. Your range is kind of the opposite of all these. Your range is going to be the set of y values. Okay, so your y values are just your range. What are my possible y values in my function, or even just my relation? And that's my range. Of course, instead of independent, these are my dependent variables. These depend on what we choose x to be. And then the opposite of input is output. All right, the next thing, vertical line test. Okay, and essentially here's the thing. If you can draw a vertical line on the graph of whatever your relation you're working with, and it only touches your graph in one and only one place, then that passes the vertical line test. Okay, so like if I were to like just talk about functions, well, you know, like a typical function might be like y equals 2x plus 5, right? It's got an x and a y in it. Okay, but not everything that I write that I can graph is a function. This is a function, but like what we did yesterday, x squared plus y squared equals 3. Okay, this would be the graph of a circle. Is that a function? Well, the answer is no, it's not. And so how can I tell using the vertical line test? Well, here. Let's just quickly draw the graph of y equals 2x plus 5. So it would look something similar to this. And so if I had the vertical line test, if I was able to go through and everywhere on my line, I was able to draw a vertical line, and it only touched that vertical line in one spot, then that would be a function. And you can see here that y equals 2x plus 5 is definitely a function. It passes the vertical line test. As opposed to, say, x squared plus y squared equals 3. Okay, that would give us a circle, the center at the origin. Does this pass the vertical line test? Well, no. Right here and in many other places, although it only has to be one place, the vertical line touches in 2 spots. And so this is not a function. When x equals 1, well, it has more than one y value, and that violates this definition up here, where each x value has only one y value. The second learning target that we're going to be picking up today is function notation. So just real quickly, the thing that you need to remember about function notation is that this phrase here, this is f of x, means a function of x. It's not f times x. This is basically replacing or equal to your y. So if I had something like y equals 2x plus 5 and I wanted to write this in function notation, well, I could simply say f of x equals 2x plus 5. The benefit to doing f of x instead of, say, y, I guess is because you can put, whatever variable is in here is the variable that you put in on the other side. So if I, now I can say something like f of 2. So it means that x equals 2. And so I could say like 2 times 2 plus 5. But, whatever goes inside here is what you're going to plug in for over here. So if I wanted to say f of smiley face, well, that would be 2 times smiley face plus 5. Okay? Whatever is inside here is what matches up over there. And sometimes you can simplify things down, like over here. I could go ahead and say that this is equal to 9, and other times I just get more expressions. All right, let's get into some examples. So here we go. Again, does every x value have its own y value? That's what we're asking ourselves. And again, sometimes you look at it and like, oh gosh, like here I have the same y value, but does that mean it's a function? Does it mean it's not a function? You can just draw a quick little graph. It doesn't have to be a great graph. A simple quick one will usually do. The point 1, 2, the point negative 2, positive 4, point 3, positive 4. Well, is this going to pass the vertical line test? Touches in one spot, one spot, one spot. Yep, this is a function. This one down here, again, oh man, is it the x's or the y's? Which one is the one that can have multiples? Well, just draw yourself a quick little graph if you need to. I got a point at 1, 1, got a point at 1, 2, got a point at 1, 3, and a point at 2, 3. Oh, is this going to pass the vertical line test? No, here it touches in 3 spots, and so we say no. Now there's other ways that we can show this to you. You can do it in a table. Again, same strategy if we get confused. Negative 5, 2, 0, 2, 5, 2. Is this going to pass the vertical line test? Yes. So there we go. This is called a map. This is, again, kind of a weird thing, but if we just draw a nice quick little sketch, we'll say, all right, 4, 100, okay, 6, 200, okay, so I guess that'd be up here. 7, 200, well, that'd be over here, but still at 200. Negative 3, 300. Pass the vertical line test? Yes. So this map describes a function. All right, there's other ways. It might give you graphs, in which case it would be super simple to tell whether or not it's a function. Does this represent a function? This ellipse here, maybe you remember that from Algebra 2. No. And in many places, our vertical line touches it in multiple spots. So we'll say, no, this is not a function, but it does say give the domain and range. So what are our possible x values that will give us our domain? Well, the domain looks like it goes from negative 4 to positive 4. So I'm going to use an inequality to describe that. X is greater than or equal to negative 4, and x is less than or equal to positive 4. My range, well, let's see. My range measures the y values, and it looks like my bottom y value is 1, 2, 3, 4, 5, 6. So it's going to be greater than or equal to -6. And it looks like I go up to 4, pretty close to +6 up here. All right. Over here, notice we've got these arrows. That kind of indicates it goes on forever this way. And this one goes on forever this way. So does this pass the vertical line test? And you can see everywhere it certainly does. Now it does get a little bit iffy. You know, this gets steeper and steeper as we go along. Okay, but does it still pass the vertical line test? Yes. Okay, it's kind of an infinitely steep line at some point, but it will still technically pass the vertical line test. So we will say yes, this is a function. And again, what is our domain and range? Well, my domain here, it goes forever to the left, it goes forever to the right. We'll just say all real numbers. And then for my range, okay, well, I do have a bottom. It's right here at -3, but it goes forever up. So I'm just going to say range y is greater than or equal to -3. All right, moving on to a different way to ask you whether or not a relation is a function. Just giving it to you as a straight up function with an x and a y. Now some of them are pretty easy to think about. So use Desmos, use your graphing calculator, graph them out, see what they look like. Y equals x plus 4 would look something like this. And so does that pass the vertical line test? Sure does. So we would say, yes, this is a function. And then domain, well, my domain goes forever left and right. So I'm just going to say all real numbers. And then for my range, well, it goes forever up and forever down. So again, I'll say all real numbers. All right, over here, again, this one is a little bit squirrely. If you were to think about graphing, it is the inverse of the y equals x squared function. And so if you were to graph this out, especially on Desmos, it'd be convenient to do so. And you would see that you get this sideways parabola. Does this pass the vertical line test? Well, here's a vertical line, and nope. Right here, whatever x value this is, I've got two y values. So we would say, no, this is not a function. Domain, though, we're looking at this. This is going to be all of my x values, but my x values have to be greater than or equal to 0. And my range, well, it goes forever up, it goes forever down. Okay, my range is going to be just all real numbers. All right, moving on. This one right here, I've got another radical. And so, again, if you just kind of use your calculator to graph this one out, here at 1, you would start, and then it would be kind of like that. So is this going to pass the vertical line test? Well, it sure looks pretty steep right here, but it is crawling to the right. And so, yes, this does pass the vertical line test. And my domain, well, my x values actually start here at 1. 2 times 1 is 1. 1 minus 1 is 0. Square root of 0 is 0. And so I'm going to say x has to be greater than or equal to 1. But my range, well, my y values start at 0, and then they go forever up here. So y has to be greater than or equal to 0. All right, the final thing here, if I were to graph this function right here, this inverse function, I would have something that looked like this, and then another something that looked like this, and there would actually be what we call an asymptote right here at 1, because you can see x cannot equal 1. 1 minus 1 is 0, and I can't divide by 0. First question, is it a function? Well, yeah, everywhere along the line here, I have one x value with, or I guess one x value as its one y value. So, yes, this is a function. My domain is simply going, well, I have all real numbers. It goes forever left, forever right, except I can't have this value right here. Okay, so I'm just going to say all real numbers, x cannot equal 1. And then my range, well, my range is going to be, well, again, I go forever down, I go forever up, but there is one other asymptote here. I can't have x equal or y equals 0. So I'm going to say all real numbers again, but y cannot equal 0. All right, so lots of different ways to ask you whether or not function or relations are functions. So that takes care of that learning target. The final thing here is just kind of in a simple way be able to use function notation. So if I said, what is f of 2? Well, here's f of x. It means I'm going to be plugging in 2 wherever I see the x. So I get negative 2 squared plus 5 times 2 minus 3. Well, 2 squared is 4, so that becomes negative 4, plus 5 times 2, which is 10, minus 3. Negative 4 plus 10 is 6. 6 minus 3 is 3. So f of 2 is equal to 3. Now what if I wanted g of t instead of g of x? Well, I'm just going to plug in t wherever I see the x. And so I have 2 times t plus 3. And that's it. Okay, there's nothing else I can simplify. The final one here says f of a plus 2. So I'm going to plug in a plus 2 wherever I see the x here. So I have negative a plus 2 squared plus 5 times a plus 2 minus 3. Well, let's see. Before I distribute this negative sign, I got to do the exponent. So I wind up with negative a squared plus 4a plus 4. And then distribute this 5, so I got plus 5a plus 10 minus 3. And, well, let's see here. Now I'll distribute the negative sign. I got negative a squared minus 4a minus 4 plus 5a. Maybe I'll combine, oops. Shoot. Well, I just finished combining those like terms, and then I'd be done. All right, that's it for lesson 3. You got learning target 6 with these ones, quite a few, but they go pretty quick, and then learning target 7, working with the function